Welcome back to Daily LeetCode. It is day 114. There have been some developments. On waking up, I figured out another cheat code. So we were using Alarmy, the clock app, where you'd have to wake up. It's an app that you can download, on the App Store, probably on the Google Play Store as well. Basically, you pick an item that has a barcode, preferably an item that can't be moved, and then you would scan the item, and it's saved into the app. So when your alarm goes off, now you have to go and scan this item. So it kind of forces you to get up. But the issue has been that you can just turn off the alarm. So what I would do is I put the barcode item in my car, so I'd have to wake up, walk outside to my car, scan it, and then that would be two things. I would be up and out of bed, I would already be dressed, and two, I would have gotten some early sunlight, which should help with stimulation and waking up. But it didn't work because you could just turn off the alarm. So what would happen was, if I stirred too much during the night, I would literally just wake up, walk over to my phone, and just turn off the alarm. Which is pretty bad, but that's exactly why they create these apps. So, for the people like me where it's hard to wake up, you need something that forces you to get the stuff done. So that was an issue. But I found another one. There's a trillion apps on the App Store. I was like, why can't you lock it? So there's actually another app where you can download the barcode app alarm thing, and this one's free. And you can lock it. So this one actually did work. So the reason you might be saying, well, you can just delete the app. Well, I have a screen time passcode set up, and I don't know the password. So with screen time, you can make sure that you can access the permissions, or you can delete or install apps, and I said that basically I can't delete any apps. So there was basically no way out of doing the alarm. And so the screen time thing is also another thing I use to stop using my phone so much. So yeah, that app actually does work. So that is pretty cool. I think I realized, though, I thought if I solved this, it'd be easier to get to work, and I realize now with the new app, I can wake up. I can wake up pretty much, and yeah, I can wake up. The issue, though, is that I didn't put the barcode in my car. Maybe I don't want to go too hard this time. I should put it in my car, but I don't want to. My brain is fighting back, so I'll have to wait till I get a moment of inspiration or enough motivation, or I have to wait till I'm in a certain mindset, so that I'll just go and put the barcode in my car. And then that way I'll be forced to get up, put some clothes on, go outside to my car. But right now, I'm avoiding doing it. So, yeah. And I guess that's kind of how it'd be. Sometimes I feel like I have to wait till my mindset is enough where it's just like, okay, I'm going to set up a lot of suffering for my future self. But that self is also me, so I have to wait till I'm in the mindset enough to be like, okay, we're definitely going to do this. But right now, I'm definitely avoiding that. So that is tough. The other issue I think I realized is that I can get up now. It's not as early as I want, but I can get up. But it seems like it's like I need something to turn me on. And I think that what that could be is physical exercise. So basically, I wake up earlier, but the issue now is that I just kind of lay in bed waiting for my brain to turn on. What I mean by turn on is like, my brain is like, okay, let's go get it. Let's go do it. Let's go do the thing. And yeah, it wasn't happening. It just wasn't happening. It takes like 30 minutes of that happening, or I'll have to browse my phone for a little bit of dopamine. And they mentioned this there's a book called The Molecule of More, which is pretty dope. And it just mentions, talks about dopamine and stuff like that. And yeah, I mean, it's like the molecule for action, so you need at least a little bit of it. And I find that in the morning I would just browse until I got like pretty much like my engine would kickstart, like a car would, and then I'd be like, okay, now I can piggyback off that kickstart and start my day. But maybe that's unavoidable, but maybe I'm trying to move it to a different area. So what I would like to do, I just bought a rowing machine, and whenever that comes, I think that could be the wave. So my plan with that is that I think running is not flames. Someone has to say it. Running is not flames. Running is just not heat. And I don't know what it is. Maybe it's the gyrating and the gribulating, but I don't know. Running is just not it. So when you're playing a sport or something, it's cool. But just running for the sake of running. I used to use the Nike Run app, and it was pretty good, but something about running is just like there has to be too many perfect like there's just something about it that's just not doesn't meld well with my personality. And I'm wondering how much of that is actually just learned behavior from gym class. But I actually enjoyed gym class, even though it wasn't that like good. I enjoyed the games, but the running, yeah, I remember whenever gym class would start, we'd have to run around the gym to warm up, and that was torture. It's funny because I do lifting and stuff like now, and I want to get bigger and stronger, but something about running just isn't it. I don't think I hate cardio though. There was one time I was on a elliptical, or maybe I just don't have I just don't have the mechanical, like the biomechanics to make it work. I don't know, but there was one time on an elliptical and a few times where I used to live at my old apartment where I would run around the apartment complex or run on the treadmill, and I actually got to experience like the runner's high, and I was like, oh, like it was like that pure unadulterated dopamine, and I was like, oh, I could see how people get into this, but yeah, it's just a hard state to reach. I'm not exactly certain why, but I definitely don't dislike cardio. I just dislike running as a vehicle for that. But I do like rowing. So when I used to go to the gym, because I know I work out at home, but when I used to go to the gym, I really enjoyed the rowing machine. So I think I'm going to try and make some fun with that. And yeah, I think I have some really high hopes for it. Even outside of the rowing machine, I used to there's like the rower machine for cardio, and there's also the rowing machine for just weights. And I would just, even though my set was over, I would just keep going. Just because, I don't know, there's something maybe because your back muscle is so big, there's just something that feels good about that entire activation. And yeah, apparently rowing uses 86% of your muscles, but we shall see. But I think that would be an activity. I think what may be missing to kickstart the day is, I don't want to lift. Lifting to start the day is I have to be in a certain mindset to lift. And lifting is just, it's just more of I don't know how to explain the mind, like the phase my mind would be in. But I could definitely see myself working out after I do cardio, or doing LeetCode directly after, because I feel like I'm already on. But lifting is just one of those things where I think what it is about lifting only removes from the bar. It doesn't give back. Whereas like LeetCode, after I do LeetCode, it gives back. Because there's more that I feel empowered to do more after LeetCode. Or after cardio. After rowing, I think I'll feel like I want to do more, like it'll give back. Whereas I think what I'm trying to say is I think LeetCode and potentially rowing have like a regenerative braking thing, where like I'm working, but also it's spinning my motor faster, or it's saving some power for later. Whereas lifting is just an expensive operation, so it just like depletes the bar. I don't really get anything out of it in terms of like making the day easier to go about. All that to say, I think I think this is like the last leg. If not the last leg, this would be if I could solve this issue. So right now I have like an hour and 30 minutes. I get up before work. If I could get up like 3 hours before, I could pretty much do my most, if not a really optimized version of my daily circuit, which would be LeetCode, the cardio, lifting, and then working on some other stuff, some personal stuff, that would be like ideal. And then after work, I would still have room. Before work, I would have accomplished everything I wanted for the day, and after work, I can just do more stuff. So, oh, that would be so dope. But that would be like the optimized circuit. But I think if we can get that going, that would be really, really good. I think that would be really, really good. So yeah, I'm thinking hopefully the row machine slaps. I will report back to let you know if it goes crazy or not. But yeah, I think the rowing machine is a piece of cardio that I can do with. Yeah, so we'll see. We shall see. And yeah, I think we have to jump into day 114. And actually, I wasn't going to mention this, but I'd like to mention it anyway. I read yesterday that, it might have been the day before. No, I think it was yesterday that Kim Jong-gi passed away. And you guys may not know who he is, but he's just pretty much legendary modern artist. Like just prolific. Like the man is just unstoppable, and it's just very sad to hear. But yeah, he didn't do LeetCode or program as far as I know, but in another sense, I think the achievement he just drew for such a long time, and I personally think he's the best on the planet. Personally, I think he's just the best artist to ever live, and I know there's a bunch of different ways to classify artists in terms of like political impact, emotional like invocation, and stuff like that. But I really think, and I think nature might agree, but I think like real intelligence is generalizable. You learn something in one place and you can do it somewhere else. And one of nature's greatest achievements of that are humans. But it's even more impressive when we get even more meta, where you take someone who is basically literally is like Blender as a human being, who can compose any 3D scene from any angle, including any items, any themes, anything you could imagine, composite it onto a 2-dimensional plane with paper and pencil in less than 30 minutes. And tons of artists have been, purported to be able to do that, but you never really know for certain. But I think Kim Jong-gi is one of those people who had such a large body of work that you can just see it. Like any item, any person, any theme, anything, any style, anything, any angle, just literally anything. And I don't know of another artist who can do it like he did. So yeah, it's just sad to see, but it's just incredible. So yeah, he was someone I think who just inspired me, because I thought like the work ethic it takes to get to that level is just incredible. So just from like a skill acquisition aspect, I was in awe. Like he was one of the people, like I started picking up the drawing again, and then the whole drawing journey eventually led me here. So it's just crazy to see. And even if you're not into art or anything like that, it's just always impressive to see, like based on a field or whatever, just what the skill ceiling is. And yeah, I'm sure there are programmers today who are probably we don't know of, or just a few that live like, apparently, I mean, John Carmack apparently is one where you're just like, you could throw this guy in any language and he would just start frying, and it doesn't matter what he's making, like it's just that long. And the skill acquisition, the work ethic and stuff it takes to get there is just impressive. So yeah, it's just sad to see, because I think programming and art as well is one of those things where like you don't really have an upper bound, right? Upper bound is really your lifespan. So it would have been incredible, because even at 47 he was just getting better and better and better. So it would have been just incredible to see what he would be creating as like an 80-year-old person. And same thing with John Carmack and other legendary programmers. You aren't really bounded by your physical capacities like you might be in like a sport. Like you'll never really see like what someone would have been at like psychologically in a sport at 80 because their body can't keep up. So there has to be like a marriage of psychological and physical realities, but just very interesting. So yeah, and also it's just sad, and yeah. So I just wanted to say that because huge inspiration. But we're on day 14. I talked a lot. We have to start talking less. And you know what? Anytime I talk more than 5 minutes, I want you guys to comment, stop it, get some help. And I'll take that as a sign so that I'll stop talking. But we're going to do 50 minutes today, and we're stuck on a problem about permutation. Oh, wait, I forgot we have a comment. He said, A2 Mad, love these intros when you stare into our souls. How else you should definitely do a video, maybe even like a devlog series of your project would be cool. You are the realist. That would be cool. I don't know how interesting the videos would be. I still have promised the 100 days of LeetCode video as well as a tutorial video. And this is the whole thing that I mean, like, oh man, it'd be nice to get the schedule right so that we could have just a more consistent way of creating content. But the project I'm creating is actually YouTube related. So yeah, it'll be cool. It'll be cool. And when I get further along, I'll start doing a series on it maybe. And that way we'll have something to go off of. But yeah, shout out to Potato Public. And we're stuck on a problem called binary watch, which has a lot to do with permutation generation. I was reading about it in the ADM. I still have no idea how to do this. The ADM seems like gibberish to me right now. We need to read more of it, and we will try our best. Let us do it. Let's try again today. I surmise we'll put in the 50 minutes remaining of today, and we won't be able to solve it. But so I was reading in the ADM, and I think turned on right as at max 10 bits, right? We want to know pretty much all the possible times we can create from that. That being the case, since we have 10 bits, we know that for each permutation, the number of operations required to generate, let's just say the permutations for 5 characters would be 5 factorial. This grows very, very quickly, usually capping out at around 12 factorial, which gives you like 400 million or something like that. But turned on is less than or equal to 10, which means that we definitely can make this work if we generate all the different versions. The only way I know how to do this is with a graph, but apparently there is a method that uses integers that you can work with based on ranking. This method only works for small numbers of permutations, which is exactly where we are. We have no idea how to implement it. So for now, let's actually try a graph-based solution. And the graph-based solution, we'll just do an exhaustive search of a binary of an n-ary tree. Is the best way I can think of how to do that. And once you reached turned on bits, we'll stop. So this is a little bit ghetto, but I think we've done this another version with a graph. So let's try this version. And the summary for this problem is that we have a binary watch, and with these bits it can show different times. So it might show 2 bits, 4 and 2, right, turned on up here, and that would mean 6, or 4 and 1 would be 5, 8 and 1 would be 9 p.m., 8 and 2 would be 10 p.m., and then there are 6 bits below which represent the minutes. But you'll notice that if you were to add 16 plus 8 gives you 24, plus 4, which would give you 28, plus 2, which could give you 30. 30 plus 32 would give you 62 minutes, and if you added 1, you'd get 63 minutes. So we know that it's possible to go over the valid bounds of the valid range of minutes. So we have to be careful about that. But we pretty much want to know how many possible times, return all possible times the watch could represent, given the number of bits that are turned on. So how we're going to do this is represent it as a graph. And we'll represent it as a graph by starting with either we'll start with a string, I think. Yeah. Basically, we'll start with the string. We'll start with a node. And basically from that node, what we'd like to do is take two paths. The two paths we'll take is one where the next node is 1 and the next node is 0, right? And from there we'll take two paths and two paths and two paths, so on. All right, dot 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 until num bits equal turned on. Then we'll stop, right? Because if we reach 9 bits, right, it's not possible. So we'll have to zero out the remaining bits until num bits equal turned on, right? And then we can also zero out remaining bits. Also, we need to start doing these on Mac because this is just a lot. There we go. I forgot the key bindings. There we go. There's like no space, but we'll have it set up here. We have 0, 1, 0 until num bits equals turned on. Right, then we can zero out remaining bits. We'll also need a way to count the number of bits that are in the current string. So we can do that. Pretty much each call is going to have two more calls that derive from it. That's going to try and say, hey, add a 1 here or add a 0 here. And we should end up with end up with an exhaustive search, which would take, I think, quite a few. It's hard to tell the time complexity, but it would be a lot. And so the function that we'd need to be able to do that, we'll call it permute. It's definitely going to take an array called generated bits, right? And this is the array that's going to store all the generated bits. And then we're also going to need access. What else will we need access to? We also need access to, turned on, right? And we'll just call this max bits. It's just a more easier. It's just easier to contextualize it like that. And then we can also call this one. We're also going to need to know the number of set bits. All right. So when set bits equals max bits, then we know when to stop. And then we're also going to want to know. We'll just call it bit string. And I think that's all we would need. We should be able to permute deeper and deeper with this. Okay, and so we'll just set up our call area. So basically, we'll just say, I think the spacing on this is messed up. Yeah, I think this is more accurate. And then what we're gonna say, right, we're gonna have generated bits is gonna equal to an empty array. Then we're gonna call permute. I'm not getting any type information or any functions. Nothing is being auto-completed or lit up. Okay, we're just gonna keep going anyway. Generated bits is gonna equal to an empty array. And we're also going to call permute with generated bits. And the three parameters were max bits, set bits, and bit string. So the max bits are going to be turned on. Set bits are going to be 0, and the bit string to start is going to be empty. Yeah, empty. And we'll just return an empty array to start. And I just want to make sure that this works. So I don't know why we're not getting any. Okay, it runs. I don't know why we're not getting any type information. But I also don't know how to minimize the test cases anymore. So we'll just leave that as is. Okay, this looks fine. And then we'll talk about permute function. So generated bits. So what we'll say is our base case is if max bits does not equal set bits, right? Then we know we should do some work. Otherwise, we know we should stop, right? But before we would stop, we actually need a few have set bits. We'll just call it the ham. We'll call it set bits. And how about the set bits and total bits? That way, right, we'll have 0 set bits, right, and 0 total bits because our bit string is empty, right? And then we can say if max bits does not equal set bits, then we have to keep going. Otherwise, though, actually we don't need total bits. There's another way we can do this. Basically, I was worried about how many bits we have to fill the remaining parts in, right? Because if we had, let's say, turned on was 4, and our string is now like this, right? And let's just say turned on would be equal to 8. We have to fill it in like this. So we need to fill in those remaining bits. And to do that, we'd need to know how many total bits there should be, but that's okay. I realize we can just do that now with set bits, with bit strings length and max bits. Well, that should be the maximum number that's turned on. The number of ones remaining is always going to be 10. So it's not based on turned on. Else we want fill in remaining bits, right? But only, right, here we can just check, right? We want to potentially fill in the remaining bits. It means we're done, right? So we might have to fill in the remaining bits. To do that, we have to check if bitstring.length equals 10. We can just do bitstring.length or we can just do 10 minus bitstring.length. And then what we'll do is we'll say remaining zeros dot times we'll do bitstring plus equal 0. Actually do it like this, but we'll just actually that doesn't make sense because we duplicate the string 4 times. We'll create a variable called, oh man, this is getting messy. Create a variable called 0string, and we'll do remaining 0string would be an empty string, and then we'll do 10 minus bitstring dot length times, we'll do 0string string plus equals 0. I don't know if you can do that, but we'll just say that you can, and then we'll fix it. And actually, we can just check if I click run. It looks like it's okay with that because it never ran. I mean, we never got to that code block. But we'll say now we can just do binary equals bit string, right? We want to combine these two strings, right? Because these are the remaining zeros, and it just could be empty, so the string won't change. And then we can just say generated bits plus equal, or generated bits dot push binary. And it actually might make more sense that we need a deduplication process in the set. So we might need a set. So we could have seen bits, and this is just going to be seen bits equal to dot new. I actually don't know if you can create a set, but we'll just say scene dot new. We'll say scene bits. And before we push it on, we'll say if scene bits dot key. So I guess we should bring this back as a separate string again. We'll say binary equals. If we haven't seen this key before, then we want to add it to generated bits. And then we would stop. And then in here, we'd also like to do some work. So if max bits does not equal set bits, then what we would like to do is call permute again. So permute generated bits, scene bits, max bits is the same. Do set bits plus 1. And then the bit string will be whatever the bit string is right now. With a 1 added, and then we'll call it again, except this time we'll add a 0. And then we won't actually do set bits plus 1 here because we didn't add a 1. We added a 0. And then I think we'll say puts generated bits. Oh man, that's so bad. That is so bad. Memory limit exceeded. I've never gotten that before. Max bits is not equal. I think the 0 is actually going on indefinitely. So maybe it's not just okay if max bits does not equal set bits. We'll say if what are we trying to capture with that statement? Max bits does not equal set bits. That we weren't done. This is also, I think we can actually keep this. And what we want to do actually might be to wrap the whole thing in bitstring.length is less than max bits. Is less than or equal to max bits. If bitstring.length is less than or equal to max bits, otherwise it's not worth the work. I think we should no longer get a memory error. Okay, that's good. Now we just get the wrong answer. I'm also realizing we're not even using, we never even added anything to the scene bits. So we're only printing out this. So if bitstring.length is less than or equal to max bits, so generated bits, scene bits, max bits is turned on. And this might be confusing, so we can just change. So we're only doing 1-1. There's a lot of different ways we could permute this. So if we have to figure out what's happening, if bitstring.length is less than, so bitstring would be 0 is less than 2. Now if turned on, which is 2, does not equal set bits, which is 0, then we want to permute with generated bits, scene bits turned on, and set bits plus 1, with the bit string being the same as it was, but with a 1 added. Bit string being the same as it was with a 0 added. What is going on here? Puts generated bits. Our output should be way more than this. So we're only running once. So then we permute again with generated bits. Set bits plus 1. And string is now length 1, which is less than 2. don't think it's less than or equal to turned on. Bit string dot length is less than or equal to 10. Okay, this actually looks pretty good. I think we might have some duplicates here. I'm also gonna put generated bits dot length 45. So we definitely have some duplicates. So I'm pretty sure their answer might be 45. Actually, we're not certain. But it was saying if we haven't seen the bits before, we'll do generated bits dot push binary, and the same thing. I'm gonna do seen bits sub binary equal true. Seen bits sub binary equal true. This should give us less. Still get 45. Maybe in the case of 3. We get 120. Now if I comment out this line, there has to be some duplicates in here. I can't understand how there'd be no duplicates. Maybe there is no duplicates the way we're searching. If so, that's pretty cool. But I don't really know why that would be. But now I have all these bits. And I think what we actually can just do now is swap out generated bits for time. And then what we'll do is we'll use the binary string to calculate the time, which we'll push onto the time array. And then we'll say time is equal to this. And then what we'll actually do is return time. We'll leave seen bits in for now, even though I'm not exactly certain that it's being used. And we have to define the calculate time function, which will, given a binary string, calculate time. I wonder how many downvotes this has. It has 2K downvotes. I see why, and I think I see why because this definitely, I think permutation generation definitely isn't an easy. But maybe the way they tell if it's easy or not is just based on how simple the solution is and not how hard the problem is to grok. But I don't know. It's going to return a string given a binary string that has 8 digits. Return a string given a binary string of 10 digits. So this isn't too difficult, as I think we just need another sub function. The first 4 bits represent, what do the first 4 bits represent? Hours. Next 6 rep minutes. Basically need a way to calculate the base 2. They both share the same base for these numbers. We can turn that base 10 number into a time. And so we need another function, base to binary, or say binary to, call it binary to base 10, and then given arbitrarily long string, calc base 10. Ow, my hip hurts. And then the way we'll do this, we just have to iterate in reverse. So we have a power, which will start at 0. We'll iterate in reverse, so we'll do 0, right, up to binary string. Binary is a string dot length, and we'll do each do IDX. So we're gonna iterate in reverse. So I don't know what's a good value to call this. We'll just call it IDX. And it's not really a good name. We'll call this offset, and then the actual IDX will be binary dot length minus offset. Except we'll go up. So if we had a binary string of like 3, we want to start at index 3. Index 2. So it actually makes sense to go to 1 to binary length. So binary length, which would be 3 minus 1 would give us 2. And then we do 3 minus 2 to give us index 1, because 3 minus 2 gives you 1. And then we have to do up to and including binary dot length to do 3 minus 3 equals 0. But I think that should work. And then we'll have value, which is equal. We'll just call this base 10. Return base 10 at the end. And then we'll do end here. Do value plus equal 2 to the power. Oh yeah, this one's just base 2. So 2 to the power, right, times binary sub IDX to I. So if we had the string, right, 101, and let's just say we were at this one right here, which would be 1, 2, 4. This would represent 4, because 2 to the 2 is 4, right? But there's a 1 there, so we want to do 1 times 4, which would give us 4. But if there's a 0 here, we would do 0 times 4. So I think that would work. Binary to base 10. And then we're saying value here, but it's called base 10. So let's say hours equals, I don't know how you do a split. I don't know how you would do a split or a slice in Ruby, but we'd say binary it looks like you can slice. So you can slice. So what we'll do is we'll just say binary dot split by empty spaces, turn it into an array, and then we will actually, maybe you can slice a string. Oh, it looks like you can slice. Okay, you can slice, so you don't have to do the split. But you can just do with array indices. So, or array style syntax, do binary first 4 bits, so 0 up to and including the 4th bit, which should be 0, 1, 2, 3. We'll say 0, 4 minutes equal 4 to 10. Say, and then we'll just do, just to make sure that we're slicing correctly, say calculate time, and we're just going to return binary. But yeah, all right, so we have too many indices, so we're missing one indice, so we want to start at 4 here, it seems. And I think if we exclude the last index, or just, yeah, 4. All right, so we have 1100, right? And then these. Wait, this isn't possible. Oh, no, we have 3. 3 are turned on. I keep forgetting. Okay, so I think this works. And then we'll say, okay, we'll just do base binary to base 10. Binary to base 10. And is it possible for hours to go over a valid amount? It is. We can do 8 plus 4 plus 2 and get 13, which would be too great of a time, I think. So calculated time will just return hours, comma, minutes. And then we can also return them together. But like they said, oh, you need to fill in the leading zeros. This is a mess. Our string, right, equals hours, 2s. And what we'll say is if hours, for example, if you have, let me check, if you have one, oh, they don't care about hours having a leading 0. So only minutes. Okay. So we don't need an hour string. We'll just say min string equal if minutes is less than 10, right? It's going to be a string that looks like minutes with a 0 in the front. Otherwise, it can just be minutes. Then we make the string, it'll keep hours as is, and we'll have the mins string, which will interpolate into here, and we'll return it as a tuple. And we're returning it as a tuple because we need to do some validation. So I have something like hours. We'll just do something like h, m, and time equal calculate time for binary, and then we'll push time into there, but only if h is less than or equal to 60 and m, oh no, h is less than or equal to 12 and m is less than or equal to 60. We'll do time dot push, or we can do time dot push if h is less than or equal to 12 and m is less than or equal to 60. There's a lot invalid radix. Line 10. Argument error. Undefined method push for in line 37. Oh. So instead of time, we'll call it times. The answer is still wrong because we have duplicate times. And we're also missing a lot of times as well. We'll also use scene bits. This is messy, but we'll also use scene bits as the hash for time. We'll say if scene bits has the key for, if it doesn't have the key for, and actually this might as well just all be an if because it's too long now. And scene bits does not have the key for time. To end times dot push time, and then scene bits equal true. Okay, so we definitely have an issue here. It doesn't seem like we're actually generating all possible. Doesn't seem like we're generating all possible versions again, but I think we're close. I think we are close. We're close, but I'm so we're too close to the end, and I'm gonna be honest. I'm about to poop a state. I think we're gonna have to call it here.